Hi, welcome to the another video of Kubernetes interview video series. And today in this video, we will look on how to explain Kubernetes architecture and its components. So with this question, the interviewer wants to know your understanding on working of Kubernetes, various components of control plane and worker node. So let's get started. So this is how a typical Kubernetes architecture looks like. Consider this worker node and control plane as VMs, and together they form a Kubernetes cluster. Control plane has API server, controller, scheduler, and etcd as its components, whereas worker node has kube-proxy, kubelet, and container runtime as its components. API server is one of the main components because it is the only component that interacts with controller, scheduler, and etcd, as well as it also interacts with kubelet running on the worker node. We as a user also interacts with API server only with the help of kubectl CLI tool or by making API calls. So let's say as a user, we want to deploy 2 replicas or 2 copies of an application, and we instruct API server with the help of kubectl CLI or by making API call. Then API server interacts with scheduler to assign nodes to these application pods. Then scheduler responds back by assigning nodes to the application pod, and the kubelet creates a pod for the application on the worker node, and the container runtime creates and runs the containers inside these pods. kube-proxy is responsible for handling the incoming traffic from outside of the world. etcd is a key value store, which is also known as the brain of the cluster because it stores the state of the cluster and Kubernetes objects. So in our current example, we want to deploy 2 replicas of application, which is our desired state. And currently we have deployed 2 application pods also, which is also our current state. But let's say due to some reason, one of our worker nodes gets failed, which also brings down our application, and our current state is not equal to desired state. So to make the states equal again, controller comes into the picture, where controller runs a non-terminating reconciliation control loop, where it watches continuously the state of the cluster and cluster objects, and whenever there is some instability, it requests changes to the API server to make the state stable again. So in our case, there is only one application pod running. Then controller interacts with API server and instruct to create another new pod to make the state stable. And as our new pod gets deployed on another worker node, our state gets stable again. Now let's discuss some few more details about all the components one by one. Let's start with API server. API server exposes Kubernetes API, and it can be configured in highly available mode. It provides REST API interface so that we can interact with it with the help of CLI or by making API calls. Communication with different components can only be happen with the help of API server only. API server also handles authorization, authentication, and admission control. etcd, as discussed, is the brain of the cluster, and it's a consistent and highly available key value store. It also stores cluster state and its related information, and it follows Raft consensus algorithm. Controller runs controller processes and helps in monitoring the cluster state with the help of API server. It has various built-in controllers such as node controller, job controller, replication controller. All the built-in controllers are combined into a single binary. Scheduler watches for newly created pods and assigns nodes to them, and scheduler does that by making scheduling decisions on the basis of resource requirements, hardware requirements, node affinity, anti-affinity, and so on. Kubelet runs as a systemd daemon on each node, and it makes sure that containers are running healthy inside the pod. kube-proxy runs as network proxy on each node, and it is one of the most important concepts for Kubernetes services. It sets network rules on nodes, which also allows network communication to pods from inside and outside of the cluster. Container runtime helps in running container as well as managing the execution and lifecycle of containers inside the Kubernetes environment. And it does that with the help of CRI, that is Container Runtime Interface Compatible Runtime. And some of the examples of CRI are Cryo, Containerd, Kata, etc. So I hope with this video, you were able to understand about Kubernetes architecture and its components. I'll see you in the next video. Thank you.